안녕하세요 여러분, 서울라인치과의 이수영 원장입니다.
Greetings, I am Dr. Lee Soo-young. I'm with Seoul Line Dental Clinic. In this master course, we are going to talk about digital implant crowns. First, digital implant crowns. The implant crowns are fabricated using digital dentistry. Usually it uses CAD/CAM. Implant crowns are fabricating crowns over abutments. Usually it uses an analog way. Digital implant crown versus digital crowns. The difference is that digital crowns do not have the word implant, so a natural tooth is prepared and scanned, or a prepared natural tooth impression is taken. From the impression, a model is made and scanned. So using one of the two approaches, the margin is set and designed, and the crowns are called digital crowns. Intraoral scanner is used to do the scanning, and margin is set and is designed. A model scanner is explained in the next slide. The digital crown compared to digital implant crown may seem easier because implant crowns would use some media to take impressions or scans, so it seems a little bit more difficult, but the reality is different. Actually, making digital crowns is much more difficult as it scans the natural prepared tooth. To scan digital crowns, not only the adjacent tooth, margin and everything should be free from errors, and the abutment form should be scanned cleanly. It's not really easy to do so. Some prefer to use model scanner. Model scanner is scanning the model after taking analog impression. There is no saliva or shiny surface. It's much easier to do the scanning. So it is much easier to do the design after scanning using a model scanner. Digital crowns can be made of zirconia or Emax ceramic materials. And for temporaries, PMMA is widely used, so you can use one of these three materials. On the other hand, implant is included in the digital implant crown. It is a little bit different. Fabricating a crown over the abutment is the same, but the abutment is scanned. After connecting an abutment for the scanning or scan body, a special media is used, and the media is scanned, and using the data, crown can be fabricated. So this is called digital implant crowns. The abutments are directly scanned using an intraoral scanner. There's a transfer abutment connected. It is scanned and the margin is set and designed. I talked about the scan body in the second approach. The scan body impression is taken. I will explain this in the next slide. So the scans are merged to acquire digital data, and over it, an abutment is designed together with the crown. When you use a model scanner, it is the same as explained before, but modeling is in the process. A transfer abutment is connected and it is scanned using a model scanner. After that, the design is the same as the one using an intraoral scanner explained before. Here also, the scan body is not scanned intraorally. Scan body's impression is taken, the whole thing. So a model scanner is used. Why do we need to use a model scanner? As there is no light reflection, and intraoral scanner would be good enough, but many people do not have an intraoral scanner yet. So when you don't have an intraoral scanner, rather than taking impression and scanning an abutment, a scan body should be connected and impression should be taken and scanned to fabricate a custom abutment. Custom abutments are fabricated using a medium called scan body. To fabricate custom abutments and crowns at the same time, and you don't have an intraoral scanner, a scan body is connected and a rubber impression is taken and sent to a lab where the process is performed using a model scanner. For digital implant crowns, these are three materials, but IMAX is not really used a lot for digital implant crowns. Really, for digital implant crowns, we need to make screw holes for ER type, and the material is rather weak, so it is not good for making holes. Usually, zirconia is used in that case. For temporaries, PMMA is used quite a lot. Digital implant crown fabrication methods. Brief introduction. There are two ways. First, custom abutment is fabricated and over it, a crown is put on. And that's called custom abutment crown. The term was coined for our easy understanding. The digital implant crown. Over a custom abutment, a crown is put on. This and the medium scan body should be used for custom abutments. The digital data from the scan body, they are not visible here, but there are virtual implants here. The data of accurate positions, depth, and angulations are already set here. Automatically, the axes are determined, so the abutments can be freely designed appropriately, considering the path of adjacent tooth and the path of invisible implants placed, or the relationship with the opposing teeth. The custom abutments can be designed and fabricated, and also the superstructure crowns can also be designed together. Depending on the crown materials, the thickness can be determined, which is a great advantage of this. As I said before, scan body impression is taken, and if points are marked, merge process begins. Implant positions, directions are determined. After that, abutments and crowns can be designed. On the other hand, stock abutment crowns, as opposed to custom abutments, transfer abutments are usually used. Sometimes a rigid abutment, one body can be used. There are two processes. Even though stock abutments are used, scans can be acquired using a scan body, as I showed you before when I discussed the fabrication of custom abutments. Actually, we do this quite often. Next, there's a library. On the computer, we can choose from the library. If you choose an appropriate stock abutment in the window, if it is selected, it appears on the monitor. Like this, it looks clean and clear compared to the direct abutment intraoral scanning obtained. It's because the digital data is superimposed over the digital abutment, so it looks very clear compared to the direct impression taking. Here, the margin is not visible clearly because it is a digital data, so the margin is clearly identified here, even though it is not visible. Later, when crown is designed, the margin, even though it is not visible here, the crown can be designed perfectly fitting the margin below. Great advantage, even though a scan body is used and stock abutment is used, the advantage of custom abutment is utilized here. Of course, there are differences between custom abutments and stock abutments, but the digital process of here is the same between the two. The impression was taken directly in the mouth. It looks irregular because when we scanned it, the transfer abutment, the metal, titanium metal abutment connected in the mouth is reflecting light, so it is not easy to take impression using an intraoral scanner because of the light reflection. So we spray over it to reduce the light reflection, which is a little bit tricky. After scanning, it looks a little bit irregular and fabrication is performed over it. We talk about custom abutment crown design. There are 4 steps like this. First, patient information should be registered, and occlusal plane should be aligned and scan body merging. Abutment design followed by crown design. Briefly, occlusal plane is set. This is the merge process. This is the scanned data. A library is brought in. For example, Austin TS3 scan body short type is used. If it is checked in the space, the scan body data would be appearing. If you mark the points where the newly acquired impression correspond to, they get attached like this. This is how the 2 data get merged. So the visible parts are matched, but the visible parts up over here are matched, but the scan body data, which appeared before in the library, below there, the implant information is hanging below there, which is not visible. So when this is merged, automatically the implant information would be attached here. So if you erase here, the implant information only would remain. That is the process of merging. Abutment design is done in a general way. If you like and select this design teeth library, automatically at number 5 and 6, the crowns are appearing. Based on the automatically suggested data, we can adjust the form. As the abutments are designed together, abutments also appear. Over it, the crown information set before is available. Inside, the abutment is designed first, so basically this appears. Left to right, front and back, the depths are adjusted. If you look at the suggested form, this should go up, and emergence profile should be adjusted, and that adjustment can be done like this. The depth height is adjusted. The height of the margin can be set at 0.5 millimeters subgingivally or equigingival height. And the emergence profile is set aesthetically. That's how the abutments are designed. The abutment size, the crown appearance that we chose before is appearing semi-transparently, and the margin of the abutment can be designed. And the height can be adjusted, and after designing an abutment, a crown design can begin. This is the first suggested crown over the abutment, and it can be adjusted in details. The abutment and the tooth margin should be harmonious, and the form of teeth morphing is done. And if it is to be splinted, the connector part of the splint can be adjusted. If you want to use an ER type, the access hole information is available here. So if you select the access hole and the diameter, the hole is automatically made. This way, very easily, the final abutments and crowns can be fabricated. Abutments is very similar. The process is a little bit different. Crown is designed first because the abutment is a stock product. After that, a screw hole should be made. The rest is the same. The margin should be set. The abutments were directly scanned, and there is no margin set here. As there is no margin data, we need to edit and set the margin information. And the crown design is almost the same. The setting values are selected, and crown needs to be designed very aesthetically. For the abutments were designed first, but here crowns need to be designed, and for splinting, the connectors should be attached. Process is the same. When screw holes are necessary, aligning holes is not easy because there is no implant access information, and we need to arbitrarily make the access information. By considering the design and access holes appropriate, the holes need to be selected in this section called attachment. So the holes and direction need to be manually adjusted, which is a disadvantage over data using scan bodies. Just like an analog approach for implant crowns, we need to consider several things. The buccolingual size should be reduced just a little bit, about 90% of the size, for long-term longevity of implants. The screw holes need to be positioned at the center. If it is not a free end case, the mesiodistal size cannot be reduced. However, for a free end case, the size can be reduced to about 90%. If there is no choice but to position the access holes buccally, as we can identify them in the design, we can consider using cementation type. I talked about using a transfer abutment and fabricating a crown on ER type. The hole needs to be made by us directly. The size and the direction of the hole should be selected, and that's something you need to consider as well. I was given 15 minutes and I have talked about the subject, and you will have another opportunity to come to a course where I talk about this all day long in a more organized way from A to Z. I'll see you in the next lecture. Thank you for your attention.